Okay, we're looking at domains and ranges for this video. Guys, let's just quickly define what domain and range is for you, just so you guys have a heads up. So domain is like where our function or where our graph exists in the x direction. So this is dealing with the x values of my function or graph, because not every graph is a function. So so we're looking in that x direction. If you guys remember, x is my horizontal axis right there, and then range is going to be my y values of the function or graph too. So you really just need to be able to look at these and be able to write what the domain is and what the range is. So if I look at this graph here, I've got this arrow, and this arrow is moving up, but it's also moving to the left as well. So this is moving up and left. And if I look at this one, it's moving up and it's moving right as well. So for my domain, I'm only curious in left to right, because that's my x-axis goes left to right. So for my domain for this one, because it never stops going left, I'm going to say that goes to negative infinity. Okay? And then because it never stops going right and there's no gaps in between, I'm going to say that goes to infinity. So I can write this a couple different ways. I can write it negative infinity comma infinity with parentheses around it, or I could write it as an inequality statement, which is just would be negative infinity, and then you use your x values here, like so. So x is greater than negative infinity, x is less than infinity. So it pretty much is the same thing. So again, it does not matter if you write it. This is what we call interval notation here with the parentheses. With the inequalities, it's what we call an inequality statement. I'm going to use inequality statements most of the time, but I'll just show you how you'd write it with an inequality as well. But interval is what we're going to do. My range for this one, my range is I'm just looking for my y values. And so this is my axis that runs up and down. Well, if you guys notice, I said this goes up. It stops going down. It actually stops going down right here at this value, which is at -1 right here. And so it goes up to positive infinity, and I always want to go least to greatest. So negative infinity is smaller than positive, or sorry, -1 is smaller than positive infinity. So we're going to go from -1 to infinity here. So I put my parentheses here. Here's the little bit of a key. If there's no open circle down here, then I'm going to use a bracket. Bracket means that it's equal to -1 down here. So if you look down here, there's no open dot here, so that means I'm including -1. That would be my interval. That's a bracket when you include. For infinities, we always use parentheses. It's just an idea. We can't ever reach infinity. If I put it in interval notation, this would be -1, and then it'd be less than or equal to x, which is less than infinity. It would look like that. So the equal to is with the bracket. Okay? Let's look at a couple more here. Here's another one. This one stops here. If you guys notice, I have this open circle, and this is just a dot, filled in dot. So no arrows on this one. So when I look at my domain for this one, again, I'm looking left to right because I'm looking at my x values. That's a -5, and it goes -5 and all the way over here to 4 because I just look at left to right. So that's going to be -5 to 4. This one has an open dot on it, so I'm going parentheses here. This one has a closed dot, so I'm going bracket there. That would be my interval notation. If I wrote it in inequality, again, you don't have to write it in both, just one or the other. I would go -5, which is less than x, which is less than or equal to 4, is what that would be. Okay? For my range, I'm interested from down to up. So the furthest down this one goes is here at -2, and the furthest up it goes is to 3 here. So when I go to write this one, we go -3, or sorry, not -3, -2 to 3. And again, what value? There's an open dot on this -2, so I'm going parentheses there, and then there's a closed one there. I'm going bracket there. And if I was to do my inequality statement, this would be from -2, which is less than y, because we're talking about our y-axis, which is greater than or equal to 3. So again, I would use interval notation, guys. That's what I usually use. But just if you see that, that's what that's talking about. Okay, I put this one on there because this one's a little bit different. This is still a function. This is just like, this is not graphed, but guys, this would be a graph of just dots here. So I'd have a dot at -1, 0. I'd have a dot at 0, 3. I'd have a dot at 2, -3, and then one at 3, 0. So I'd have a dot here. I'd have a dot here. I'd have a dot at this spot and this spot. So there's no lines with this one. When there's no lines, when I go to do my domain and my range, I just have to use what we call set notation. So my domain, all I'm going to do is just list my x values. So my x values, I'd say the x, and I'm going to go colon here, and then I'm just going to list them. My x values are at -1. They're at 0, because this is at 0, and then they're at 2, and then they're at 3. And we usually go from least to greatest with that. And then I usually put these squiggly brackets on there as well. So that would be my domain that I'm looking for there. Okay, and then my range, I'm just going to list the points. And I have to list them like this because, guys, my graph does not include anything between -1 and 0 because there's not a line. Okay, so for this one, I'm going to go y, and then I'm just going to list them from least to greatest. I have one at -3 here. If I keep going up, I have 2 of them at 0, but I only need to list one of them, so I just put 0 once. And then I have it here at 3 as well. And that's what I put for my range, is that. Again, it just exists at those points, so we don't need to do an interval. The interval serves for us not having to put, like, every point. It just says, hey, we're going from here to here. But when I have points, I just do that. Okay? I could also see this, like, maybe you guys have seen mappings before when you have like, your X and your Y here, and it like draws these arrows to some of these values like this. If this was like, I don't know, -5, 0, and 2, and then this was like, I don't know, 3, 4, and 5. If I was to write my domain for that, it kind of already has it organized for me. This would just be -5, 0, and 2, because those are my x values. And then my range is just going to be my y values, which I'm just going to go 3, 4, and 5 here would be my y values. I just need to actually list them in nice set notation. So I have to use this notation for points or those type of things. When I have lines, though, I can use my interval notation like this. Okay? Last thing I want you guys, so we've looked at domains and range from a graph, from like relations, so points. And then what about if I just have equations here? How do I deal with those, guys? So to deal with those, this is what you should think. And I only want the domains on this one. So this, I'm only going to ask you for domains for equations, not ranges. So just domains, no ranges on this. Okay, so if I look at an equation, there are two situations that are different. If I have a rational like this on the left and I have a square root, I have to treat them differently. To find the domain of a rational, guys, it is going to be all real numbers, so all numbers except what makes my denominator equal to 0. So x cannot equal, in this case, -5 for that one, if you guys notice. So this is what my domain is. So whenever I have a fraction, I just look at my denominator and say, okay, it's all reals except for what the denominator can't. If I put this in set notation, this would be negative infinity to negative 5, like so, with parentheses, not including negative 5. And then it would be negative 5 to infinity. So that helps just exclude that. So I could list it like this, all reals, or I could do it in set notation like that. So let's say I had another one here. Let's put another one down here that's a fraction. Let's say I had like f of x is equal to x minus 1 over x minus 7. So this one's domain would be all reals, except for x cannot equal positive 7 in this case, because it's only the denominator. I can't divide by 0 is essentially what I'm saying. Again, if I wrote this in set notation, this would be negative infinity to 7, and then 7 to infinity, because there's like that gap that's in between there. Okay? So that's with rationals. If I see a square root, I don't ever want to take the square root of a negative number. So what I need to know is what makes x plus 5 greater than or equal to 0. I need to know what makes that. And in this case, if I minus this 5 over, that means that x is greater than or equal to negative 5. Which, if I look at that, if I plug in negative 5, that gives me 0. If I plug in like negative 6, it gives me negative 1. So I need my values to be greater than negative 5. So my domain for this one needs to be everything from negative 5 bigger. So that would be negative 5 to infinity, guys. So negative 5 and bigger. Always put parentheses there. It can be equal to, so I'm going to put a bracket there. All right, let me show you another one here. Let's say I had like g of x is equal to the square root of, let's say, x minus 9. And I said, what is my domain for that? Well, again, I have my square root, so I know that x minus 9 has to be greater than or equal to 0. So I'll add my 9 over, add the 9. So I have x is greater than or equal to 9 at that case. I need everything 9 and bigger. So to write that for my domain, that should be pretty simple. All we're going to do is go from 9 to infinity in this case. Bracket on this side, parentheses on this side. Okay? Those are your two situations. Everything else is all reals. So all reals for everything else. So notice how this is just x squared plus 3. So this is not a square root and it's not a rational, so it's all reals. Or we can put it as negative infinity to infinity for my domain. So my domain for anything that's not a rational or a square root that I just saw in these other ones is all reals. So I could have g of x is equal to like 3x minus 1. My domain, again, it's not a square root and it's not a rational. This would be negative infinity to infinity. Okay, it's just that's how it is for everything else that we're going to be dealing with right now. When you get into Math 3, you're gonna see there's a couple other functions that don't, but for what we're doing, that's what we're looking at. Okay, this has been your Math Moment with Money. Adios.